Okay, so you want to find density for an unknown solid here. This one's a little more tricky because you're probably confused about which volume you need to use. So let's do an example of a problem like this for question 3. So remember, density is mass over volume. We have the mass, no biggie, 85 grams. Now, here's what you need to understand about the volume. To help them find the volume, they use something called water displacement. So that's where you can take anything, fill it up with water, measure how much water there is, and then once you put the object in, however much that water rises, you subtract the two, and that's that object's volume. So let me show you what I'm talking about. So in this case, you're going to fill a graduated cylinder to 10 milliliters. So that's 10 milliliters. You put your object in, so it's your unknown solid, and when you do, the water is going to rise to 15 milliliters. So to find the volume of the object, you need to take your final volume minus your initial volume. The final volume, in this case, is 15 milliliters, because that's what the volume went to after you dropped the object in. Your initial volume, so what you originally filled the water up to, was 10 milliliters. Subtract the two and you'll get the volume of the object, and you'll use that in your density equation. So 15 minus 10 gives you 5 milliliters. So volume of object equals 5 milliliters. So we'll plug that into our equation. 85 divided by 5, that gives me 17 grams per milliliter. Now, I know you're like, well, Miss Newell, you always said that for a solid they use centimeters cubed to measure its volume. They do, but in this case, since 1 centimeter cubed equals 1 milliliter, technically it should be 17 grams per centimeters cubed, technically, but given your answer choices, it's all milliliters, and they give you the units of milliliters. So we're just going to stick with milliliters. So it'll be 17 grams per milliliter. So use this process, this example, to help you answer question 3 correctly if you got it wrong.